categorical data, which is part of Chapter 1. So I want you guys to take a second and look through pages 2 through 4. You can pause this video as you do that. All right, so one of the first important things that we want to think about is what is the difference between categorical and quantitative variables. We really want to focus on who is being measured and what is being measured. Our categorical values are usually words, while our quantitative variables are usually numbers. So do we ever use numbers to describe the values of a categorical variable? Do we ever divide the distribution of quantitative variable into categories? We want to remember that categorical variables are recorded with numbers, so like area codes. Also, often quantitative variables like age, height, weight, standardized set scores, and so on are divided into categories and treated as a categorical variable. So it depends on how you want to use this data. If you want a percent in a category, it's categorical. If you want an average, it's quantitative. All right, so here's some information about 8 randomly selected U.S. residents from the 2000 census. All right, so notice how in our column with state, we have all these words, the different states. Number of family members, we have numbers. Age, we have numbers. Gender, we have either females or males. Marital status, we either have married or single, and we got separated. Total income, these are number amounts. And lastly, travel time to work, which are also number amounts. So looking at this chart, who are the individuals in this data set? What's going on in our rows and columns? All right, so we have our 10 randomly selected U.S. residents. What variables are being measured? So in these variables, which ones are categorical and which ones are quantitative? So our categorical are our state, gender, marital status. Remember, those were all words. Quantitative, we have the number of family members, age, total income, and travel time to work. Those were all numbers. Those could be measured. So describe the individual in the first row. So this person is a 60-year-old married female from Kentucky who drives 20 minutes to work and has a total income of $21,000. She has 2 family members in her household. Next, we're going to talk about what a distribution is. So a distribution tells us what values the variable takes and how often it takes these values. Note that values can be words or numbers. So next what I want you to do is display the distribution of gender and distribution of number of family members for the sample. So go back and look at that sample of the census and figure out how would you display the genders and how would you display the number of family members. Give it a try, and then let's look at the next slide to see what I did. So notice how for number of family members, I used a dot plot, yet with the genders, I used a bar graph. Okay, so now I want you to try it on your own. Take a look at the Check Your Understanding on page 4. Give that a read, and then come back to these questions. So who are the individuals in Jake's study? All right, the cars in the parking lot. What variables did Jake measure? Identify each as categorical or quantitative. So we have the car's model, which is categorical, the year, which is quantitative, color, which is categorical, number of cylinders, quantitative, gas mileage, quantitative, weight, quantitative, and whether it has a navigation system, which is categorical. All right, continue reading on pages 7 through 11, and then come back. So next we're going to be talking about what is the difference between a data table, a frequency table, and a relatively frequency table. When is it better to actually use that relative frequency? So our data tables list individuals and frequency tables summarize the distribution of a variable. If we want to compare distributions of like radio stations in Tucson, it'd be better to use the relative frequency. What is the most important thing to remember when making pie charts and bar graphs? And why do statisticians prefer bar graphs? Well, the biggest thing is proper labeling. If you're not labeling it correctly, it's really difficult to read it. It's easier to make it, to compare it, and it can be used when a pie cannot. So like comparing the percent of success in multiple groups, for example. And then what are some common ways to make a misleading graph? All right, well, first of all, violating the area principle. It should be proportional to the frequency. Don't start the frequency axis at 0 and making 3D graphs. All right, continue reading pages 12 through 18 and then come back. So firstly, what is a two-way table? What is a marginal distribution? And how do we display a marginal distribution? So basically, the distribution of a single categorical variable, so like a gender or response only, we're going to display these with a bar graph. That is our type of table. So what is conditional distribution and how do we know which variable to condition on? So the distribution of a categorical variable for one category of another one. So like the distribution of response for males. So we're just looking at males and seeing what they said versus anyone else. Remember that there are two sets of conditional distributions for a two-way table. So then what is a segmented bar graph and why are they good to use? So with segmented bar graphs, it forces us to use percents, matches the structure of a two-way table, and it's also called a stacked bar chart. When does it mean for two variables to have an association, and how can you tell by looking at a graph? So firstly, knowing the value of one variable helps you predict the value of the other. For example, if knowing that a person is male makes one of the responses more likely, then there's an association between gender and response. Two examples of these types of graphs. So one with no association and one with an association. So we have gender versus handness. So like, do females, are they right-handed or left-handed? Or males, are they right-handed or left-handed? There's not much association with that. Where gender versus long hair, you could say during a certain time period, it's more common for females to have longer hair. So there would be an association with that. All right, so here we have a chart about cell phones. So the Pew Research Center asked a random sample of 2024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. And here are the results broken down by age category. So, things I want you to do here are display the marginal distribution of cell phone, explain what it would mean if there was no association between between age and cell phone type. Display the relationship between age group and cell phone type using a segmented bar graph. And based on this graph, is there an association between age and cell phone type? So firstly, this is what we got. And then obviously we're going to be using a bar graph. And this is what you should have here. All right, lastly, here is your classwork. It will be due Thursday,